separating clutter so that the information is readily available. As was said earlier, it should be the best information, not much information. And we have the data model underlying it, and if it is maritime and universal, call it UMDM, Universal Maritime Data Model. Well, modeling is different than encoding. For example, you see here this AAS application-specific message, which is a specific way to transmit data by AAS, but it's an AAS-specific encoding of certain data objects. Another example is XML. It's another example of encoding. It contains the data modeling, but it's hidden from the foreview. What again benefits of separation? We want to have an encoding-free essence of data to be treated by humans and machine. We want to have seamless derivation. We want to be technology independent. We do not want to have any limitation of technology imposed early on. And we want to have unique identification of data objects, possibly. Don't get me wrong, we need specific interfaces eventually that will do data exchange, but only eventually. Now, something which is dear to the heart of my group is the so-called IALA navigation stack, and this shows the context of the data model. On top of the whole show, of course, is user needs. And user needs inform user requirements and information needs, some of which have been stated in great detail, others are still to be stated. These inform now the data objects and their properties. And these again are used for data encoding, which then is being used for the system layout at large for technical e-navigation service when it comes to data exchange. So again, the same picture, still expanded. We are going a little bit deeper into the hierarchy. Over here, one claim would be strive for a unified operational presentation service. Unified means unification on a functional level, so that it looks similar. Then we would say, again, the data model, if maritime and universal, call it UMDM, so universality is a very important thing, and that really is a powerhouse for engineers. You can build any system by having such a data model. And then, of course, you would need to have a exchange format, and that's Maritime Data Exchange Format, MDEF we have called it. And last but not least, we would like to have common shore-based system architecture, which we are also developing. So this is a full stack, and every single statement herein is a program rather than a name. And my time doesn't allow it to elaborate on this, but of course you will see the documents in ENAV 8. What does universal imply? All IALA stakeholders should be involved. It should be global in scope with regional amendments. There should be harmonization and unification where appropriate. And so we identified already two aspects where we would like to have unification. That's a so-called data object identifier and a property identifier. And we would like to have gradual absorbing contributions and rigid version control. Data objects and import properties or types, well known to programmers. Properties incorporate the knowledge base. Properties can be simple or complex. And again, data objects can be simple and complex. So there's a recursion running over here as well. We have a lot of flexibility, and that's a requirement. We have 3 dimensions over here. We can put knowledge into the data properties, both complex and simple. We can put knowledge into the data objects by combining different properties, different data objects. And we can put flexibility in the combination when it comes to exchange. And that's again another dimension of flexibility. Of course, there are always general and specific properties, general being fundamental things and specific being specific to a certain operational field of application or a certain technology. We structure those into ontological trees, constituted of categories, subcategories, branches, and data objects. This is an example for traffic objects, individual vessel, vessel as such, vessel identity, and the data object eventually is vessel name, for instance. And we have developed a structure for the universal maritime data object. This is kind of a car plate for a data object. By this thing, you would be capable of recognizing the data object which follows in a stream of data objects uniquely. And it again consists of the very same group of categories, subcategories, branches, and data objects, plus adding a version number, which provides a fourth dimension in terms of flexibility, namely evolution over time. That's the life cycle management. We ventured into defining categories and subcategories. This is an example. I don't have time to go into details, but I would like to simply share with you that it's informed by the Dewey Decimal Classification Principles, i.e. from the library science, and it has over 100-year history and knowledge base behind it. Benefits. Each and every data object of the whole maritime domain, uniquely and unambiguously identified wherever it appears. That's one of the major benefits of the UDOI. Flexibility. And the same data can be used in different technology. And what you see down here, it can be also encoded in different ways and using different interface formats, such as well-known XML or 61162 or whatever, using the very same data description model. Now, coming to the strategic consideration, IALA has already announced to IMO that we are doing work on Common Maritime Information Data Structure, and we already identified this in our ENAV 140, in the thing which is called UMDM. And this is how we think the process could be. That we, first of all, develop an IALA UMDM as contributions from various committees and projects, absorbing, harmonizing, re-engineering their contributions. We learned in the meantime that IHO has developed a universal hydrographic data model, and there we propose preemptive harmonization. So we get together with IHO and try to use the best of both worlds and put it together so there is no overlap. And this could be repeated by other international bodies. And of course, eventually, IMO will give a rule base, or maybe in parallel, so that the whole thing is controlled, while IMO does not itself develop the library. Well, and that's my presentation so far. Thank you very much indeed.
Thank you, Jan Hendrik. And the final presentation in the graveyard slot is Dirk Eckhoff, a colleague of Jan Hendrik. And Dirk is going to talk about putting the shore-based e-navigation system architecture to work. Dirk is an electronics engineer specializing in control systems with the Traffic Technology and Telematics Division in the Directorates North and Northwest of the German Waterways and Shipping Administration. He is responsible for technical management of VTS systems and has been a member of the IALA VTS Committee Technical Working Group. Dirk.
Thank you. Yesterday night on the industrial members evening, we got another ENAV device. You didn't hear right. EAR-NAV device. You listen, and as soon as you hear the engine of another vessel, you probably should recheck your course. So, right away. I'm the last in the row here. I have no time limit, do I? Okay. Putting a shore-based ENAV system architecture to work. 10 years experience report. When starting a project, when you start a project implementing a new system structure, you have several phases. shown here, analysis, design, specification, realization. In Germany, we didn't start right away going through the process. It was really a phase overlapping and also iterative step.